Good morning, mathematicians. It is Thursday of week 4, and we are starting off thinking about customary measure. We're thinking about customary capacity. And one thing that you need to make sure you know is this relationship. In 1 gallon, there are 4 quarts. We need to know this relationship in order to answer this question. So let's start with what we have. We are starting with 9 gallons and 1 quart. And what are we losing? We are losing 2 quarts. So to lose 2 quarts from this quantity, obviously, we could cross off this 1 quart. We no longer have that, but we're also going to have to take one of these gallons, which leaves us with 8 gallons. Now, if we have those 4 quarts that we would cash out, one of those we would have to give in order to get the 2 quarts, and that would leave us with 3 remaining quarts. We can think about this in the opposite way too. If we have 8 gallons and 3 quarts, if we added 2 more quarts, 1 more quart would turn this to 9 gallons, and we would have 1 quart left over. So we would be back to our starting point. Now, let's use similar thinking in our problem number 2. We're starting with 13 gallons, 1 quart, and 1 cup. Now, this time we are not losing a quantity, we're actually adding a quantity. So when I look at this, I'm going to be adding 6 gallons to my 13 gallons. I'm going to be adding 3 quarts to my 1 quart, and I'm going to be adding 1 cup to the 1 cup that I started with. So let's start over here on this side. If I have 1 cup and I gain another cup, I have 2 cups. Now, if I have 1 quart and I gain 3 more quarts, I have 4 quarts. But instead of writing the 4 quarts, I can actually cash that in to an additional gallon, right? So I'm actually going to say that I have 0 quarts and I'm going to add 1 more gallon. And I'm able to add this gallon because of this moment right here. 1 quart plus 3 quarts gave me an additional gallon. So now I have a gallon, 13 gallons, and I also have 6 gallons. So together, that is going to give me 20 gallons. The answer to this question is 20 gallons, 0 quarts, and 2 cups. Okay, let's switch gears and let's come here. This question, we are thinking about volume. This says to sketch a rectangular prism that has a volume of 36 cubic units and label the dimensions of each side of the prism. Well, I'm going to go ahead and start sketching. I'm going to draw my initial face like that. I'm going to imagine that this goes back away. Oh, that's looking pretty good. Notice the way that I am sketching. And of course, sometimes you got to kind of clean it up a little bit. And now I need to label the dimensions of each side. So when I multiply my length, my width, and my height together, it has to equal 36. And this is where your answer and mine may differ, and that's okay, as long as length times width times height equals 36. Well, I right away recognize that this is an even number, so I'm going to make one of my dimensions 2, and I'm going to make my height dimension 2. Now, if I have 36 and I divide 36 in half, I know that I have 18 left, right? So I know my answer needs to be 36. I'm going ahead and I've used 2 here. So now I know that this number times this number, when I multiply those together, we need to be 18. Because 18 times 2 gives me 36. So here I could do, of course, 9 times 2, or I could do 6 times 3. Either of those would achieve what I need to get to 18. So I'm going to make my length 6 and I'm going to make my width 3. Now, notice, boys and girls, when we plug this in, my length, width times height, 2 times 6 times 3, all of that equals 36. And that's really what I was tasked to do in this problem. So your prism and your dimensions might be slightly different than mine, but we should be the same in that when we multiply our three dimensions together, we get to 36. Now, let's go to our next question. William Shakespeare makes 468 bottles of Shakespeare soda for his friends. If each of his friends gets an equal share, how many bottles will each get? So I noticed that we have this number, 468. And what does 468 represent? Well, it represents the bottles of soda that he wants to share with his friends. Now, each of the friends is going to get an equal share. It didn't say he and his friends. It says he's giving them to the six friends and they're getting an equal share. Well, that tells me right away what I need. The magic sauce to answer this question is going to be division because this is my whole. So therefore, this is my dividend. And it is being broken into six groups so that each of those is going to get an equal quantity. We can divide this with whichever your chosen strategy is. I'm going to go ahead and divide this with some partial quotients. But again, that's the great thing about our division strategies. You can do the strategy that makes sense to you, particularly here where it doesn't tell us a specific strategy that we need to do. Now, I'm going to go ahead and give each friend 70 bottles in my first swipe because I know that 6 times 7 is 42. And then I have 1 0 outside that basic fact. Now, because I did that in my first take, notice I've already sorted a lot of those bottles. I have 48 bottles left to sort. So now I'm going to give each friend 8 additional bottles. 8 times 6 is 48. So now I've used all the bottles, and that means that there's no remainder. So I know that 70 plus 8 is 78. And what does that mean in context of the problem? It means that each friend is going to get 78 bottles. Now, this last question has multiple parts, and I love the way today's column is really helping us to practice so many different math skills and so many different domains of math. Here, we're actually thinking about some of our fourth grade standards with shapes. Now, the question says, classify the below triangles based on their side lengths and angle measurements. And it even gave us some of those key vocabulary words that we know in terms of how to classify a triangle by its sides. When I classify a triangle by its sides, I can call it equilateral, isosceles, or scalene. I call it equilateral if all the sides are equal. I call it isosceles if two of the sides are equal, and I call it scalene if no sides are equal. When we say equal, we're talking about the length measure of that side. If all the sides have exactly the same length, it's equilateral, right? Now, notice in these shapes, they have given us with geometric shorthand everything that we need to know to be able to say if it's scalene. For example, here, this side has one of these notches. This side has two, this has three. That means that all of these sides have their own measure. None of them are the same. So I know that this is a scalene triangle, right? Now, yes, we're going to also call it by its angles, but let's just start first with the word that we would use to classify it based on its side. So this is scalene because no sides are equal. Now, when I look at this particular triangle, I notice that look, this side, and this side all are shown with one of those notches. That tells me that all the sides are equal, which tells me that this is equilateral. Equal sides, equilateral. All the sides are equal. It is an equilateral triangle. Now here I note that this side and this side have two notches. This side does not have two, so we can infer that it is not the same measure. So therefore I know that this is that last remaining side. This is isosceles because two sides are equal. We have classified our triangle based on its sides. Now let's classify it on its angles. So again, notice, and I tried to kind of separate this, like hopefully we classify and separate this in our brain. These are the words that we call it based on the length measure of its sides. These are the words that we call it based off the measure of the angles, right? If all the angles are acute, it is an acute triangle. Now, all the angles have to be acute to be called an acute angle. The reason being, you can also have an angle that has one right angle. If one angle is right, it is a right triangle. The other two angles are going to have to be acute in order for the entire triangle to have 180 degrees. The same thing happens in an obtuse triangle. In an obtuse triangle, you have one obtuse angle where it is greater than 90 degrees. The other two angles will have to be acute for that angle to work or for that triangle to work out to have 180 degrees. So the takeaway here, boys and girls, is that we classify a triangle based on the largest angle that it has. Here, for example, all the angles are acute. So the largest angle that it has is acute. They are all acute. All three angles are acute. So we call this an acute triangle. And in its best classification, we call it acute equilateral because we've classified it by its angles and its sides. Okay. Now, when I take a look, let's go back up to this top one. This is an acute angle. This, excuse me, this is an acute angle. The largest angle right here is obtuse. And when I look at this one, the largest angle is right.